I did was you've got a sheet with the two graphs, with degrees. I'm starting with degrees because we know that graph last year. So I put tick marks there on the x-axis. I put tick marks on the y-axis, and I've given you the coordinate points. The reason I'm starting here is they ask you to do transformations. Based on the scale they give you, you might be able to use all of these points. You might be able to use some of the points, but you need to know the pattern, okay? So the pattern is very simple. It's going in 15 degrees. The reason it's going in 15 degrees is when we go to radians, you'll find that pi over 12 is the most useful because multiples of that can make pi over 3, pi over 4, pi over 6, pi over 2. So it adds up to special angles. That's why I put it to 15 degrees. I've labeled the y-axis so that you can get the special points. So if I was graphing this, knowing all those points gives you really detailed information. And to be clear, the points are not that difficult. You've got 1, 0. You've got 0.97, 0.26. Then you've got 15, 30, 45, 60, 75, 90 is 0, 1. This one is 0.26, 0.97. This one is 0.5, 0.87, 0.71, 0.71. This one is so what's the pattern? At this point, like, I just want to clarify something. I don't expect you to memorize the entire unit circle. That's not the idea. The idea is you know these key points, and you use the symmetry of the different quadrants to find the missing one in combination with the cast rule, which I'll try to teach you when we do equations. But look at the pattern. X is 0, 0.26, 0.5, 0.71, 0.86, 0.97, then 1. Y starts at 0, 0.26, 0.5, 0.71, 0.87, 0.97, 1. There's only 5 numbers. These two, they're almost never used. So it's just really 30, 45, and 15, right? But if you know that there's a point missing, then it's easier for you to graph. So if you know all of those points, you just follow them along on the dot. So if I was trying to graph sine here, sine of 0 is 0. Sine of 15, 0.26. Sine of 30, 0.5. 45, 0.71. 60 is 0.87. 75 is 0.97. And 90 is 1. If you know all of those points, right, it becomes a lot easier for you to graph. The key ones are 0, 1, 0, -1, 0. Or what happens in between, that shows you the curvature. And then from there, you just go backwards. So I've got this one. So 15 degrees will go down. Point 0.26, 0.5, 0.71, 0.87, 0.97, and -1 at 2.7. There. there. So this is a full graph, and now you can see that it's got a maximum at 90 degrees, a minimum at 270. It's 0 at 0, 180, and 260. Okay. That's the general shape. I gave you another graph, another grid, so that you could graph cosine. The only difference is cosine will start here and end of the map. Those 5 key points, right? The 3 zeros, the max and the min. That's what's important about cosine, about the sine graph. You'll see that from 0 to 90, first quadrant, sine is positive. 90 to 180, second quadrant, sine is positive. 180 to 270, third quadrant, sine is negative. 270 to 360, fourth quadrant, sine is negative. This makes it clear that for the top half of the circle, sine is positive. Bottom half of the circle, sine is negative. Okay? And then we just have to graph cosine. So I'm going to take it a little bit slow today. I'm just going to do the base, sine, and cos. And I'm just going to do A and C. So we'll just keep it to things that can be caught up on. Okay, so this is really still like almost like 5.1. So here are all the numbers. If you want to just try plotting them on your graph, I'm going to do the same thing for the cosine, and then we'll compare. So 0 degrees, my cosine is 1. 50 degrees, it's 0.97. 30 degrees, it's 0.87. 0.71. 0.5. 0.26. 0. 0.26. 0.5. 0.71. 0.87. 0.97, negative 1, 0.97, 87, 71, 5, 26, 0. First quadrant, cosine is positive. Fourth quadrant, cosine is positive. Second quadrant and third quadrant, cosine is negative. So I'm going to start with the two easiest parameters so that tomorrow I can catch up to people who work here. And the first parameter is first one we're going to look at is A. So A is your vertical stretch if it's a number greater than 1. The reflection if it's a negative number. And if it's a fraction, it's a vertical compression. Okay? So I've got two sides. The first side is equations that we're going to graph. The second side is graphs that they've given us that we're going to figure out what the equation is. Anyone not get a sheet? All right. So let's look at the first one. We're looking at vertical stretch or compression. I'm going to start with my first graph. And to help you, I'm going to draw just my base graph to show you how it's stretches. So my base graph might look like for sine theta, my max will be there. My min will be there. And my graph should look like that's just sine theta. 0 to 1 to 0 to -1 to 0. That's the base graph. This 2 is telling us that all the y values get multiplied by 2. So it's easier to do it with a almost like a mapping. So 0 times 2, 0. 1 times 2, 0 times 0. Sorry, 0 times 2 is 0. -1 times 2 is -2. So your graph's basically getting. Now, here's what I was trying to talk about. If you know all of the key points, you can kind of do something, but here's the basic shape. So it stretched it vertically, all the y values got multiplied by 2. Instead of the 2, try to visualize what would happen if you have the -2. I'm going to cheat using this graph. I'm going to change the color to purple. The -2 essentially is going to take this purple graph and flip it. And so y equals -2 cosine will look like the purple graph. You get it? So let's look at how that would work, okay? So I'm going to take this graph that I kind of already know the answer. And I'm going to show you how I get that answer from here. Okay? So for sine, my base value is 0. If I multiply 0 by -2, I get 0. For sine, my maximum value is 1. If I multiply 1 by -2, zero times -2. Remember, my sine curve, my min would be here. 1 times -2. Sorry, -1 times -2, +2. 0 times -2. And so that's why our graph. So basically, instead of the max being up, it flips. Okay. The key thing is the difference between the top graph and the bottom graph. In the top graph, it's just vertically stretched. The bottom graph, it's vertically stretched and it's vertically reflected. Okay. Okay. We don't have to start at the positive. We can work directly on this negative. Let's see what an example would look like. For my cosine graph, I know that my max is at 1. My max of 1 is at 0 and at 2 pi. My min is at pi. And I've got zeros there and there, halfway between the max and the mins. So this is what my cosine graph would look like. That's just cosine. To get the graph I want, I have to multiply my key y values by -2. So positive 1 times -2, 0 times -2, -1 times -2, 0 times -2, +1 times -2. Does that make sense to you guys? Okay, let's do the difficult one. So here's my cosine. I'm going to multiply all my key y values by 2. 1 times 2, 0 times 2, -1 times 2, 0 times 2, 1 times 2. So two things that can happen is they can give you an equation with transformations and ask you to say what the transformations are. They can give you an equation and ask you to graph it, or they can give you a graph and ask you what's the equation, right? So that's what I'm going to do on the reverse of that. Good luck again. And what might help is if you actually imagine the base function So I'll sketch it in there. So you notice that it asks you for an equation and it specifies here I want the sine equation. Whereas the other graph I've given you cosine. Okay? So if this is a sine equation, I know that my regular sine curve might look like this. So it looks like my 1 became 2, my minus 1 became minus 2. So it looks like I've got a vertical stretch of 2. So this equation looks like y equals 2 sine theta. Just the vertical stretch. Okay? To help me with my cosine graph, it's actually kind of neat. Sorry, I'm showing off for a second. But you see the minus 1 square? Minus 2 squares. See the minus 1 square? 2 squares. Minus 1 square? 2. Sorry, 1, 2. The maximum of 1 became maximum of 2. The minimum of negative 1 became a minimum of negative 2. So this looks like 2 cosine theta. There's my base cosine graph. Now, instead of minus 1, it looks like positive 2. So I know I've got a vertical stretch of 2. My positive 1 max has moved to a min of minus 2. So it looks like this is minus 2 cosine theta. Sketch it. Am I going too fast? So there's my sine curve. My max of 1 became negative 2. My min of negative 1 became positive 2. And again, you can see something here. You see the 1 square? 1 times minus 2. The 1 square, 1 times minus 2. Negative 1 times minus 2. Negative 1 times minus 2. In terms of squares, not numbers, right? So this looks like minus 2 sine theta. So the idea was that the first couple of things that you read through in that section, the first couple of things will tell you about a vertical stretch, of oppression or reflection, and a vertical shift up or down. Because those two things are the easiest one. The next two things that we do rely on you having done the readings, because they talk about the period of the wave, how many cycles, and phase shift. So if you've actually done the reading and processed it, I can show you how to graph it. Okay, that's why I delay everything. So today I'm just going to do the first 4 sheets. Tomorrow we can move on to either period or day shift, and then it should be good by like Wednesday. So I'll do it over 3 days. Shouldn't feel rushed, then you have time to process it, and then you can rest on the weekend because we're doing equations after. Okay. What I might do is do the easy equations on Thursday so that you can practice the basics. And then when we come back, we'll spend some more time on equations. Okay. If you're worried about when the test is, because usually that's what people are most concerned about, there's no test this week. The earliest the test would be next week, like maybe Thursday, Friday, but even that seems rushed. So probably the week following. Okay. The only thing is you have to be aware of the following. The last 2 chapters, 6 and 7. Actually, that's not a problem. We have, yeah, you got enough time. I'll finish chapter 5 next week. Then we just spend the day after studying for it. And then after that, I don't need a lot of time for 6 and 7. Those are a little bit easier than the trade. So we'll spend the time on the thing that you guys actually need more time and effort than wrapping up, and then we'll move to the last 2. We should be done. Last day of instruction is the 21st of June. So we should be good. Okay. All right. Can I move to the next example? Actually, yeah. Ready for the yeah. I'll just talk fast and not bother about what you get it. All right. So here's the next one. Vertical translation. Okay, so now we're focusing on that. So I've got sine theta minus 2, cosine theta plus 2, 2 sine theta plus 1, minus 2 cosine theta plus 1. So we mix first, I'll just show you C and then A and C. So sine theta minus 2. Well, my sine theta graph will look like this. Sine theta minus 2 will look like this. It's just the whole curve moved down 2. So 0 minus 2 minus 2. 1 minus 2 minus 1. 0 minus 2 minus 2. Minus 1 minus 2 minus 3. 0 minus 2 minus 2. So it's the C is just a translation. It doesn't change the shape. A changes the shape. C just changes the vertical location. So there's my cosine graph. So all you're doing is, okay, you guys all have like your smartphones and stuff. So you can visualize this next one. It should be the easiest one for you. Okay. So watch what I'm doing here. That's a very bad cosine graph. So the deformity here. Just in case people are watching. All right, so all you're doing is taking this graph and moving it up 2 units. It's literally a copy and paste, and you're sliding it up. Okay. The reason we focus so much on sine theta is because vast majority of natural phenomena can be modeled by the sine graph. And everything else is just a transformation of the sine graph. Okay? So we okay with a straight translation down and a straight translation up. Now we do two at a time. So we're looking at sine theta. So here's my sine theta graph. So the 2 will stretch everything, and the 1 will add 1 to the y. So your strategy for this is take the y value, multiply it by 2, and then add 1. 2 times 0 is 0. 0 plus 1. 2 times 1, 2. 2 plus 1. 2 times 0, 0 plus 1. 2 times minus 1. Minus 2 plus 1. 2 times 0, 0 plus 1. So the idea of having that image in your head of sine in the basic position means that now you can look at this and you should be able to say minimum, 0, maximum, 0, minimum, 0. Oh, this is my sine curve. And you can just color the notes. Cosine graph. So same thing, take your key y values, multiply them by minus 1, and then add 1. Sorry, let me say that again. I make mistake. Take your y values, multiply them by minus 2, and then add 1. So minus 2 times 1 is minus 2. Minus 2 plus 1 is minus 1. Minus 2 times 0 is 0 plus 1. Minus 2 times minus 1 is positive 2. Positive 2 plus 1 is 3. Minus 2 times 0 is 0 plus 1. Minus 2 times 1 is minus 2 plus 1. And that should look like a cosine curve upside down. I know like these seem like ridiculously easy examples, right? But I'm just trying to get the concept across. Now, once you have the concept of easy numbers, you can apply it to the other ones. When we have all four of the parameters, A, K, D, and C, hopefully it'll get a little bit less trivial. So we looked at graphs with the transformation. And the only thing left is finding the equation. Okay. Is this a little bit clearer than last year now that you've seen it for the second time? Okay, so vertical translation. So the first curve they asked us for is sine. Okay, so I'll show you how to decode it. So that's your base sine graph. Got a max of 1, got a min of -1. Okay. Now, first thing you notice is that instead of being at 0, you're at 2. That could not be A, because A times 0 is 0. So this must be the C value, because it got moved up. So the 0 is at 2, 2, 2. So that sounds good. Now, it's been moved up from 2. What's the amplitude? So here are the zeros, correct? It goes from 2 to 6. So that's an amplitude of 4. So here's the thing. You see the 4? That tells you the max and the min, but you've got the +2. So the 4 means that instead of going from -4 to +4, with the +2, you're going to go from -2 to 6. -2 to 6. So your amplitude checks out and your phase checks out. So your graph would look like this. And if you're ever not sure how to get your A value, right? Here's your midline. You're going 4 up from 2 to 6. You're going 4 down from 2 to -2. So your amplitude checks out. Instead of being at 0, you're at 2. And your vertical translation checks out as well. So there's my cosine. Obviously, the amplitude has been increased. And the phase shift. I'm sorry, the vertical translation. So here's how you look at it. See, the max here is 5. And the min is -3. You see that? Okay, so to find out the amplitude, it's just high minus low divided by 2. So 5 minus -3. Minus is plus. 5 plus 3 is 8. 8 divided by 2. Amplitude is 4. Can we verify that? Yes. Here is my midline. From the midline, I go 1, 2, 3, 4 up. 1, 2, 3, 4 down. So my amplitude checks out. Instead of my midline being 0, my midline is +1. How are we doing so far? Anyone lost? Okay, you're in room 311. You're not lost. Okay, next question. Can I move this off? So here's another cosine graph. You can see that my high value is 6. My low value is minus 10. Okay? 6 minus minus 10 is 16. 16 divided by 2, 8. My cosine is not reflected. It's in the same natural position. But instead of my midline being at 0, my midline is at minus 2. Any questions on that one? That's our last sheet. All right, so now the last one is sine theta. You can see by now, how much you have learned already from your readings, you can tell that this is sine theta with a reflection. Because instead of going like this, it's going like this. Okay? Your midline is 4. 4 plus 8 will give you 12. 4 minus 8 will give you minus 4. Do you agree? So that means my amplitude is 8. But it's not just 8, it's negative 8 because of the reflection. Normally, my midline would be at 0. Here, my midline is at 4. That's why that curve. Yes.
Question for that, you're doing, you're like trying to put out the most like. But if you do it, there's.
John. No, no, no. Okay, so there's a lot of time left. In the 180 seconds you have left, you can just relax. Tomorrow we'll move on to the other parameters. Okay. Sorry, did I say 180 seconds? I meant 5.
Oh, okay. I did.